Okay, the last video was about factoring binomials. This one is about factoring trinomials. When you're factoring trinomials, it works just a little bit differently. You can use trial and error, or you can use the box method like we did when we did a binomial times a binomial to factor trinomial. It's just basically foiling backwards. But you got to be careful and watch your signs, because when you have subtraction involved in your trinomial, it gets a little tricky. So you have to be careful and watch your signs. The first thing you have to do when you factor a trinomial, if you're using the box method, because that is the way I'm going to teach you and show you right now, is to draw a 2 by 2 box. Remember, when we're doing a 2 by 2 box, that means we're multiplying a binomial by a binomial, which means each set of parentheses only has 2 terms. You will put once you draw your 2 by 2 box, you put the quadratic term, or the term x squared, in the top left square of the box, and the constant goes in the bottom right corner, bottom right square of the box. To find the linear term, you're going to multiply the value of a times the value of c, which is the coefficient for the quadratic and the constant together. And once you multiply a times c, you're going to list the factors for the product that you get. And then you want to choose the factors from that list whose sum is going to give you the value of b. Okay? So b, the value of b in the equation ax squared plus bx plus c. Alright, so we're going to try an example. So here's a trinomial, x squared plus 7x plus 12, which is on your sheet that you have, that you were given before you left for spring break. The first thing you want to do is draw your 2 by 2 box. So I drew my box, and I put the quadratic in the top left square, and I put the constant in the bottom right square. This is the quadratic, this is the constant. From there, I multiply the value of a times the value of the constant. A, in this case, would be a 1 because there's no coefficient in front of that x squared, which automatically defaults to 1. So 1 times 12 makes 12. So I listed my factors of 12, 1 and 12, 2 and 6, 3 and 4. And I'm trying to pick out the 2 factors whose sum also will give me the value of b, which is 7. Because 3 plus 4 makes 7, I went with the factors 3 and 4 to use in my box. So then I just place those in to the empty boxes, 3x and 4x. And at this point, it doesn't really matter if you put 4x here or 3x here, because it's all addition. So it doesn't really matter where you place the 3 and the 4x. But it does matter in subtracting. Okay, so once I do that, then I determine what 2 things multiplied together gave me x squared. X times x gave me x squared. And if I have a 3x here, then I need to know what times x gave me 3x. And that has to be 3 times x. So I put a positive 3 here. So 3 times x gives me 3x. X times x gives me x. And then I work my way down here. So x times something has to give me 4x. Well, the only way to get 4x is by multiplying with x, is to multiply the x by 4. So this is going to be 4 right here. So then I know that I have to multiply 4 times 3 and get 12. Alright, remember, you have to use the correct integer to get the correct value for b. So in a problem where involving subtraction, which you'll see in a minute, you have to make sure you put a negative sign for one of these if you need a negative b value. So to review that one more time, when factoring trinomials, first draw a 2 by 2 box. Put the ax squared term in the left top square. Place the constant in the bottom right square. And then find the product of the value of a, the coefficient a, and c. And then list the factors for that product. And choose the factors from that list that will give you the sum for b. Now, this one is going to involve subtracting. And the first thing I did was wrote my quadratic. X squared minus 4x minus 21. And then I put my quadratic term in the top left box and my constant in the bottom right box. This time I have a negative constant, which lets me know that one of these terms is going to be negative. And I forgot to put my negative on this term right here. So one of these terms are going to be negative. All right. So now I have my x squared and my negative 21 here. I multiply the value of a times the value of c. A times c is 1 times negative 21, and that gives me negative 21. Now I make a list of all the factors that make 21. Well, 1 times 21 makes 21, but 1 plus 21 doesn't make negative 4. Or if I did negative 1 plus 21, that wouldn't give me negative 4. Or if I did negative 21 plus positive 1, that wouldn't give me negative 4. So I defaulted to the 3 and 7 because that's my only other option. Okay, I have no other factors that make 21. Since b is equal to negative 4, 3 and 7 could be used or should be used because I know I can get a negative 4 by adding these two numbers. This is where you have to remember to use the correct sign, the correct integer. All right, so I chose the 3 and the 7, and I know that one of them has to be a negative in order for me to get a negative 4. Now, if I have a 3 and a 7 and I want a negative 4, I know the bigger term has to be the negative because that's going to determine what the answer is, the sum is, based on the largest absolute value. So the absolute value of 7 is larger than 3, so I need for my 7 to be a negative integer. To check to see if I got the right answers, because I have x plus 3 times x minus 7, to check that, I can do the box, putting these numbers on the top and along the side and checking to see if these come out just like this one, or I can use FOIL, x plus 3, x minus 7, to see if my answers come out right. And they do. They all check out right because x times x is x squared. Negative 7 times x is negative 7x. Negative 7 times 3 is negative 21. And negative x times 3 is 3x. If I use FOIL, then I'm saying x times x is x squared because that's my first term in each set of parentheses. Then my outside terms are 7 and negative 7 and x. So x times negative 7 makes negative 7x. My inside terms are 3 times x, which makes 3x. And then my last terms are 3 times negative 7, which makes negative 21. I can combine like terms here, and negative 7 plus 3x is negative 4x. So x squared minus 4x minus 21 is what I get, and it's what I was hoping to get, and that's the correct solution. Alright, so on your paper that you brought home from spring break, you only have to do the left-hand side of the paper. The right-hand side of the paper has coefficients for A, and we're not ready for that yet. So only do the ones on the left-hand side of the paper, and have a great spring break.